I have a laptop motherboard here. This comes from an Aftershock gaming laptop. The model is Vapor 15. So depending on which country or where you're from, you're likely to find the exact same laptop, but maybe a slight difference in the design under a different brand name like Sager, Eurocom, Metabox, XMG, or whatever. So what they do is they get the parts and the same motherboard from a China manufacturer, assemble it and stick on their own labels and logos and sell them as their own. Now let's take a look at the motherboard. This comes with a 10th gen Intel CPU and an RTX 2070. So there's a hole here in the board which I made to clear some shorts because the chip at the back was badly burned and the PCB was damaged. I had to dig through the board to clear the shorts. Now let me just show you a before photo of what happened. So this is a photo of what I saw when I first got the motherboard. And you can see the chip that was burnt here is actually an integrated MOSFET driver that delivers the Vcore voltage to the CPU. And what happened was the 19 volts of the main power rail was shorted to the ground as well as the Vcore of the CPU. So you can imagine 19 volts going into the CPU. That's a disaster. The CPU had no chance to survive. Here's a closer look at what I've done to fix the board, and I did not manage to take a video of the process because I don't have a recording microscope, but you could probably see what I've done here. It's just a lot of filing and scraping through the burnt layers of the PCB to clear the shorts, and I've replaced the chip and patched up some of the broken traces and pads over here. So the circuit should be pretty much fixed now, but we still have the small matter of a dead CPU to take care of. So before I start to replace the CPU, let's take a look at the current status and somewhat voltages, because I have cleared the shorts, so it should all be showing up. Now I plug in the power and you can see that we have some standby current there. So we should get, this is the 3 volts and 5 volts. And of course the PCH 1 volt. Okay, let's turn on the power. So you can see the current going up to around 1 amp and it got stuck there. And that's not because of the RAM, because I have the RAM installed here, so something must be wrong. And of course it's the CPU side of things because that's where the damage was. So if we measure the Vcore, nothing. There's nothing showing up. So here, and we do get the RAM voltage though, and we do get the VRAM, and we do get the graphics core voltage as well. So what we're lacking is the Vcore to the CPU. Nothing. Okay, so clearly we have to replace the CPU. Let's get started. So the CPU is removed and I've cleaned up the solder pads. You can see there are no damaged pads, so it looks pretty good. Now we just need to replace the chip with a good working one, but I do not have a spare chip lying around, so I've ordered one from China, of course, and it's here. It's the exact same chip as the one originally on board. It's an i7 chip, 10th generation, so you can get an i5 for a cheaper price, but the price difference is not that much, so you might as well go along with an i7. So the chip came by default with lead-free solder, so I prefer to work with leaded solder because it has a lower melting point and it's much easier to work with, has a higher chance of success. So I'm gonna have to reball this chip with my leaded solder balls, and then we're gonna solder it on board. Alright, so the CPU replacement is done. Now let's power on the board and check on the current status again. So remember we got stuck on 1 amp at the bad CPU earlier. Now let's check on the new one and see how it goes. Let's turn on the board. Okay, so we can see the current going up and drops back down, and then it goes up again. Now that's a good sign. And we're getting 2.67 amps now. That's looking pretty good. That's a lively current, it's bouncing around a little bit. Okay, so now let's check on the Vcore that was missing earlier. We should be getting something now. And we get 0.78 volts. That's good. Now I want to check on something else that's important. So remember the burnt power phase that I fixed? I want to make sure that it's actually producing an output. Even though we got a Vcore reading, but we can't exactly tell whether it's coming from that power phase because the outputs are all linked together. There are 4 power phases here. So to check that, you have to use an oscilloscope and look on the waveforms. Let's turn the board on again. Okay, so let's check on the output on that phase, and we got a waveform here. Okay, so it means that it's working and producing an output normally. So the rest of the power phases, this is phase 2, phase 3, phase 4, which I don't expect any problems because they were not damaged to begin with. So now we can hook up a display and see if we get something on screen. Thank you for watching. I'll see you again.